And this is supposed to be with the POP, right?
What does it mean?
POP is
I know what POB means, but
no, the slides that Hannes was supposed to do.
Hannes is supposed to be talking about pop architecture, as far as I understand.
I know.
It's related, but I think it doesn't really depend on pop architecture.
How much time do I send this?
But maybe you kind of understand for
It might have. It might.
sometimes end up in
Yeah, I haven't seen this. Can you put it on a stick or send it again or something?
Good morning.
So viel zu sagen haben.
You'll find a spot for you. Okay. How much time do you need?
5 to 10 minutes. So we could also discuss about this number once he's coming in. So,
Okay. Okay. That's fine. Good. Thanks. Okay. Where's your slides? Yeah. Yeah. Yes. Okay. Okay. Good morning, everyone. Welcome to OAUTH, the second session here. Oh, my mic. Let's go going. So this is our note well. This slide governs our conduct and any IPE. I don't know, but still. So make sure to be aware of this, and if this is your first time seeing this, please make sure to read it. Okay, next. So we have a Jabber scribe, Ludwig. Thank you for that. We have a note taker, Tony, again. Thank you. Appreciate that.
Wants to volunteer.
Anybody? Okay. Thanks, Tony. And
Mike does.
Mark is busy. Okay. So here's our agenda. Okay. So we will probably shuffle this agenda during the meeting. There was a request for a late request for something to add 5 to 10 minutes, but we'll see. So we'll start with Hannes to talk about the OAUTH workshop update. Then Aaron will talk about the browser-based app. Hannes maybe take less than 30 minutes to talk about POP. And Torsten will talk about MTLS, and I will finish it with a quick talk about nested chart. Ready? Yeah. Yeah.
So some of you attended the OAuth security workshop in Stuttgart last week, and others didn't, unfortunately. We had a very good event, and I will give you a short summary of what we did and where you can find the material. In this small, so this is obviously the web page. I posted a link to this one to the mailing list. We had record participation. We actually had to close the registration at some point in time because the meeting rooms only, or the meeting rooms had a limit. And of course, having discussions also makes it more difficult with 100 people. For the first time, we organized it in a way that we had tutorials, we had the regular talks, we had an unconference style presentation. We also invited a keynote speaker. The tutorials focused on two aspects: formal methods, or the use of formal methods, in this case Tamarin, for protocol verification. And basically it was a hands-on tutorial, so you can find the slides there, and I believe the slide also contains a pointer to the virtual machine, so you can get the environment set up and running if you go into this. The other one was a hands-on tutorial on the use of access control with OAuth in a sort of cloud context. We then had a wide range of talks, and here's the full program. And since some of the participants were newer to OAuth, or at least to these type of events, there were introductory talks as well. Mike talked about OpenID. Thorsten gave a good summary about what's going on then in the OAuth security, BCP, and so on. We also had then the unconference where participants could pick the topic that they like particularly. We did a show of hands on who is interested in what and divided up the groups. So you can, those obviously were, there were no slides for those, and unfortunately also no notes, but still, so you can get an idea what people cared about. And then the keynote speaker talked, John Manico, talked about cross-site scripting attacks and how to prevent them. And it was a very detailed talk, I would say. The slides are also uploaded, so take a look at it. Even if you know cross-site scripting attacks, going through all the different mitigation techniques and the libraries that he recommends, I think is a very valuable resource. Nat did the recording of some of the talks, and I've asked him to send me the recordings and so that we can upload them, but that hasn't happened yet. So I hope this will be available at some point in time so you can actually get a good idea what's going on. So take a look at the slides. There's some really good stuff in there. That was it. Yeah.
Okay, thanks, Hannes. I think Aaron, ready? Perfect. This one. Yeah, go ahead.
Thanks. Hi, I'm Aaron Parecki. I'm Sorry I couldn't make the security workshop last week, but I'm glad David was there to talk about this draft there. I am, I want to give a quick update on the browser-based apps recommendation that we've been working on and kind of talk about where we're at with it. And then also there's a bunch of open questions that I have on it that I want to talk about, especially based on some of the recent changes to the security BCP. So can you change the slide for me?
You can drive.
Perfect. Look at that. So the high-level overview of this draft is that it provides specific recommendations for people building browser-based apps, and the definition of browser-based apps in this case is an application that is written entirely in JavaScript that is running in a browser context that does not have its own backend. As soon as you have a backend for it, then you kind of get into a different world, and you can do real OAuth with provision secrets and things like that. So the sort of quick overview of the points that the spec recommends is that it requires that browser-based apps do the authorization code flow with PXE, and it explicitly disallows returning access tokens in the front channel, which effectively is saying don't do the implicit flow. And there is a point in there that says that these apps have to use the state parameter for CSRF prevention and requiring exact match of redirect URL registration, and that browser-based apps should not get refresh tokens. So all these things were things that we talked about at the Internet Identity Workshop in October, and we kind of brainstormed some ideas around like what do people currently recommend for these kinds of apps, and this was the list that we came up with, and I've digested that and turned it into this document. So some of these I think are now, as the security BCP has been progressing, some of these things I think we need to reevaluate. So some of the high-level questions that I have for this draft so I had originally envisioned this app would be, or the spec would be talking about specifically pure JavaScript apps running in a browser with no backend component. And as we've been talking about this and progressing the document, some people have chimed in and said, well, there are other architectures where people are building effectively single-page apps that do have a backend component, even if it's just sort of to manage, proxying API calls to other backend APIs or something. So one of the questions here is, should this scope of this document explicitly include those? And if that's the case, I think it needs a little bit of restructuring of how the document is laid out. Or should it be limited to just the pure JavaScript app case? With the recent point that we brought up in the security BCP of, you have a question?
Torsten, do you want us to stand up and give comments on that questions, or will you guide us through the questions and then we can?
Why don't we have time here, so why don't we just go in order? I have these three, and I have like 4 that are like really specific questions on the next page, and those are the questions I want to talk about here. So yeah, if you want to jump in.
Tony Nadlin, so are you ruling out, it's hard to tell here after reading the paper and stuff, if you're ruling out just pure JavaScript apps, not under a browser. So
not under a browser.
Yeah, there's
in
environments, devices, and things that run pure JavaScript.
Oh, sure.
So I'm trying to determine if you're ruling those out of this thing or not.
Sure. Yeah. This is so this is meant to be recommendations for apps running in a browser, which right now mostly are written in JavaScript. That is probably not always going to be true. So this is not a JavaScript recommendation. This is a browser-based environment recommendation. So yeah, I would say that like JavaScript apps that are running in non-browser-based environments don't fall under this, because those are just, they have their own considerations. Like some of those might be considered native apps.
Just wasn't clear.
Yeah. Okay. Thanks. Yeah.
Torsten, 2 remarks. First of all, we shouldn't really narrow that to only JavaScript apps. You already mentioned that. I mean, basically what we're talking about are apps that are running in the user agent, and a specific specific characteristics of that environment because you don't have direct access to, for example, certificates, can't do MTLS and all that stuff. It doesn't matter whether it's JavaScript or any other language that's being used there. First, and second, I'm not quite sure whether it really makes sense to narrow the scope down that much as you have done. And I already commented on your draft. I personally haven't seen a pure SPA in the wild in my professional career. Yeah, I might be the only one, but from my perspective, this is an academic concept. As soon as you go multi-user, you somehow need to have a shared state among your instances. And if you have a shared state among your instances, I don't think you will directly expose the database to the JavaScript app. So you will have some kind of backend component. If I take a look onto standard environments such as Spring in combination with Node.js or something like that, there are plenty of templates that you just instantiate, and they give you an Angular front end and a Spring backend. And that's the default architecture I'm familiar with in our environment. So I think this scope is too narrow. We should broaden it up, and it also gives us more architectural options, how to really protect this kind of SPAs.
Cool. So thanks. So my question on that is, in an environment where you have a single page app front end with a Spring backend or something like that, are there enough recommendations in the existing documents that cover that deployment scenario, or are there things about that scenario that are unique that should be described by this document?
Obviously, if you have a backend, then you can, for example, move all the OAuth code to the backend and just tie the session via an HTTP only origin restricted cookie to that particular backend.
So, yeah.
So, in a lot of issues that we are talking about are going away, and in particular, I don't think it's a good idea to manage any kind of security relevant data on the front end, because the user has access to that data and can modify it.
Yeah. So I agree. So my question is that already described by the security BCP and like the regular, core OAuth, or is that?
Okay. I misunderstood your questions. Sorry. No, it's not, because the security BCP is intended to be generic as possible, and we haven't included any recommendations for example, SPAs or native apps, because for native apps we have the native app BCP, and for SPAs, yeah, we have the SPA BCP. So, for example, recommendations on the use of CORS, although we have discussed about that. So Daniel discussed about that with Neil Madden from ForgeRock on the list. We haven't included that in the security BCP because it's obviously specific to apps running in the browser, and we didn't want to put that all into the security BCP.
Okay, cool, thanks.
Ludwig Seitz relaying a comment from Justin from Jabber. We should mention things like SPA with proxy-backed apps and generally put them out of scope. Specifically, this draft should only deal with things that see the auth tokens inside the browser, but we can't ignore that people follow other patterns, and we want to steer them in the right direction. And namely, those should usually use cookies between the browser and the backend, and not auth in the browser.
Thanks. Okay, so that's the completely opposite opinion here. So that's sort of what I wanted to discuss. So Justin's saying this document should only cover cases where the browser has the access token and is really the browser is the one doing the OAuth flow. So that's kind of where I'm like, where should we fall with this?
So, John Bradley, Yubico. If I understand Justin correctly, and even my opinion, these apps in the browser aren't just one thing or the other. They may have a back end, but they may also be using OAuth tokens in the browser. So just because the app has a back end doesn't mean that if it's getting and wielding OAuth tokens directly, that this BCP shouldn't apply to it. So this should apply to any app that's using OAuth directly with OAuth tokens, managing those OAuth tokens in the browser. Yes, a different pattern, which Torsten is legitimately recommending, is You could move all of your OAuth to your back end, but some people may choose not to do that for a number of reasons. So we can say, for apps that choose not to move all of their stuff to a back end, all of their OAuth calls to a back end server, this is how you protect the OAuth functionality that you're going to keep in the single page app. So this is about apps that do OAuth in the browser, not excluding apps that may have a back end.
Okay. Yeah.
That
Yeah. I think that's a good distinction there.
right. We don't want to. We
It's
don't want
not
people
about-
going, "Oh, I have a back end, so I don't have to pay attention to all of this."
Right. Right.
This OAuth advice, even though I'm actually doing OAuth. Having a back end doesn't necessarily help you unless you're actually doing all of your OAuth through it.
Thorsten again. I think there are two kinds of OAuth in the browser. One OAuth in the browser means you have an application that has a user interface that's running in the browser. And this user interface somehow interacts with the OAuth authorization server. So it somehow initiates authorization requests and it receives authorization responses. How those responses are being processed doesn't matter. I mean, in the native BCP, we don't exactly describe how the front of a native app and potentially the backend are interacting with each other and what the boundary is between them for good reasons, because we don't care. It's up to the software developer to design that. And that's one way you can look into that. Yeah, an SPA, from my perspective, is just another user interface for an application. And the internal application architecture is a completely different thing. So it has to receive an authorization request. The important point, and that's where it comes to the second view on OAuth in the browser, is does the front end that's running in the browser also process the authorization response, which is just one of two options, right? The user interface can just path the code or whatever. No, it's supposed to be the code to the backend, or it can just directly call the authorization server, redeem an access token. Those are different options, right? And from my perspective, we should discuss both.
Okay.
It's both OAuth in the browser, right?
Yeah. Yeah. Thanks. Yeah.
Ludwig Seitz again, relaying Justin from Jabber. Thorsten and I don't actually disagree, I think. I'm saying talk about it and put it into the right scope, not covering it and not mentioning it. Not covering it and not mentioning it at all are two different things. I think we should mention it and not cover it, like what John is saying. You.
Did he actually say that, or you're just editorial?
No, that's what we actually wrote.
You wrote that. Oh.
Okay. So
usually not agree with you.
Well, there are principles involved.
So what I'm hearing is the particular architecture of your browser-based app is not necessarily the important distinction here. It's whether or not the browser and the JavaScript or whatever code is running in the browser is at all actually involved in the OAuth flow, either initiating it or redeeming a code or handling an access token, and that should be the scope. And then we describe the different architectures within that. Okay, that is great. I would and any other points on that, because I do want to get to some of the other questions here. I think that's very helpful, though. Thanks for the input there. Okay, so with the sort of the high-level scope question out of the way, I wanted to get into some of the more particular details of this, especially as they relate to the security BCP, as that has been evolving as well. So I know that one of the recent changes that was discussed this week was that the security BCP is now going to say that Pixie should be used for the CSRF protection, and that freeing up the state value to be used for application state alone. That is not currently, that's actually not allowed in this, as this is written, because this actually says specifically use the state for CSRF protection. Should this follow suit? I'm kind of inclined to say yes, unless there's a particular reason that the JavaScript or the browser-based environment is different.
DanielFetYes.com, yes, we should do that.
Okay. Yeah, my instinct was to just follow suit, but I wanted to just throw it out there in case anybody else has some other information. And along those, sure.
ThorstenYes.com as well. We just have talked about that. So we haven't really come to a conclusion because the chairs first want to send a posting to the list to get a feeling on a sense of the working group, but we had a tremendous positive feedback. So we're gonna update the security BCP, but that's not in there yet. But if you follow suit, that's perfect.
Sure, yeah, that's an important point. I guess along that line, should we roll in the change to this with that same request that goes out to the list for feedback, since they're very related?
So Tony Nedlin, we have lots of apps that we have to crawl through to make sure that it's not going to break anything. So it's not just a quick decision. We've got 45,000 apps or so. So we've got to make sure they wind up in this particular space. So we have to figure some stuff out.
My understanding of that change is not that it's going to break any existing implementations. It's just saying that you can use state.
We don't know if it will break yet. So I mean, with the state,
if you are using state for CSR protection, there's no reason to change that. It's just that if you are not doing it right now, then you will now be compliant with it as long as you're doing Pixie.
So yeah, further to that, state will continue to be opaque to the server. Nothing, it's an option for a client to use Pixie instead of state. Every application currently using state, the 2% that actually correctly use state for CSRF protection will continue to work properly, and the rest will continue to be broken.
Phillips Coconut 0. The security BCP also talks about using or favoring S256 over the plain one. So we must make sure that the JavaScript applications do not actually or do have the necessary resources to calculate those properly.
Literally on my next slide. That was one of my questions.
All right, perfect.
Yeah.
Hey, Annabelle Backman, AWS. Maybe we should have brought this up the other day with the Pixie change, but if we do go forward with the change to recommend using Pixie for CSRF and not state, I think we will want to include some note to the effect that this does not necessarily mean that state itself should not be CSRF protected or somehow bound to the user agent or otherwise protected, but that is purely up to the implementer or the client to decide depending on what they're putting in state. But I think it would be risky to imply that state does not need to be protected in this fashion.
So I guess how this relates to the browser-based doc question is, if the security BCP is going to go forward with this plan, is there anything unique to the browser-based environment that we need to mention in this, or can I basically just remove all mention of state because it's already covered by the security BCP now?
I don't want to try and answer that in 5 seconds.
Yeah, sure. But that's my
yeah. But
I'm getting at.
Torsten again. My proposal: just let us discuss through all those topics. So Pixie and then the Pixie mode and so on. Come to a conclusion. I'm totally agree with Tony. We first have to do our analysis, and as Philippe pointed out, we have also to check whether the SHA-256 mode also works for all kinds of applications. So I think we have to sort that out, and then we document it in the BCP, and we can write it up in the BCP so that other app-specific BCPs can just refer to the recommendations section. I think that would be the most efficient way to integrate those. Yeah.
I wanted to add to Tony's remark. I think it's good to look at the existing apps and to see how many of them comply with the recommendations we are making here. But it's also, as we discussed in other contexts, the best current practice document is supposed to illustrate the best current practice. It's not necessarily what we do today. There may be actually a disconnect between what we recommend going forward as sort of a kind of a visionary, at least to a certain extent, not like there's a fine line between sort of trying to steer the community in the right direction versus being overly ambitious, unrealistic potentially. So we need to keep that in mind as well. But if you guys look at your stuff, your installed base and see what works for you today and what complies, that would obviously be very useful information.
So yeah, along these lines, the last point here is there anything else that's being described by the security BCP that either does work or does not work easily in a browser environment that we need to handle differently here? And that's too big of a question to answer right now, but that's kind of what I'm thinking about how this document fits into the rest of the ecosystem. So that's something I would like everybody else to keep in mind as we're working through this. And I think we should probably have more of these discussions on the list offline since they're kind of bigger questions. But that's what I'm looking for of like in the security BCP. Is it saying anything that is like too hard to do in a browser that we need to address differently, or is it saying stuff that we should make sure you do in a browser where the security BCP maybe says it's optional, things like that. So with the remaining time, I have a couple of specific questions, which I would love some feedback on from people who have experience here. So let's just go through these really quick, and I think this will probably take us to the end of this segment. There was a in the original discussion of this back in October when we were whiteboarding it out at IIW, I took a picture of the whiteboard and then it was there, and I was trying to figure out where this came from. But there was an idea that there should be an option for browser-based apps to do hostname only whitelisting of the redirect URL. And I have that, like that's written up on the whiteboard, and I can't remember who said it or where that motivation came from, because that is not exact match redirect URL matching. And I don't remember why that's there, but now it's in the document, and I want to see if anybody has any recollection of or any experience with a deployment scenario where they're doing a browser-based app environment and matching only on the host name of the redirect URL to sort of allow like a pseudo wildcard redirect URL. That throws up red flags to me, because everything else about OAuth says you should do exact redirect URL matching. But there was something about the browser-based environment and JavaScript environment that suggested this was an option. And I would love to remove that if that sort of exception here, if there isn't a good reason to have it. So does anybody off the top of their head have any scenario where you would want to allow a sort of wildcard match on the redirect URL that matches only the host name?
Annabelle Backman, AWS. Not exactly, but thinking about the problem where I've often seen clients want this sort of feature is where they want to be able to get back to whatever context they were at within the app. So in the case where you have not necessarily a single page application, that's still possible doing everything in the browser. I mean, usually the way we tell people to do that is have a single redirect URL endpoint that extracts from state where you're supposed to go back to. That's still possible in the browser, but it does mean having to push more of that logic into JavaScript. And so we have to think about how does that work, what libraries are available to support that in a secure fashion. Which doesn't necessarily mean we have to change our guidance here, but there's probably room for giving some examples or some guidance on how do you address these issues. Maybe this is something that should really be in the security BCP, I don't know. But I think this is an area where the specs have been a little bit weak as far as pointing people in the right direction.
Okay. Ludwig Seitz again, relaying Justin from Jabber. I don't remember someone saying that in the session, but I think they're wrong. So I would guess, that's my own editorial comment, I would guess if someone said it, I think they're wrong, was what you wanted to say.
I'm going to raise Justin, and they're definitely wrong. But I agree with Annabelle. We have to give, I mean, again, we get back to state and people misusing it or not understanding what it's for. So providing advice either in the BCP, the security BCP or this BCP about actually not just whacking on query parameters because they're convenient, which is the way that people traditionally maintain state in OAuth, but put it in the state parameter, and also discuss integrity protecting the state parameter, because there are possible attacks. If you allow people to start injecting state into your app, interesting things that are hard to analyze may happen. So there's probably some advice that we generally want to give about state, if I think about it. Oh, well, I mean, there is, separate from my signed state draft. I mean, that might be a way to do it, but we should probably generally mention that these are the things that could go wrong with state, and why you might want to integrity protect it or properly do CSRF.
Thorsten, just clarifying question. You're proposing to add something about that to the security BCP?
Yeah, I think that the misuse of, if we're going to talk about moving CSRF into PXE, there are other things that can go horribly wrong with state, so we should at least mention them, and mention that this, getting the user back to the right point in the app is really what state is actually supposed to be used for. So we can mention that that's the way that you should do it, and shouldn't just allow wildcard redirects.
Annabelle Backman again. I will go a step further and say we should actually think about revisiting like a sign or a state as a JOT kind of specification, instead of just punting this problem to the client. Actually give them a potential solution that covers as much of the bases as can be generalized.
So I'm okay with reactivating and allowing the work group to add whatever it wants to the signed state draft. I'm not sure if we've actually adopted it as a working group item, but there is a draft there that's been kicking around for years that some people use.
Daniel Fett, I'd just like to highlight that if you use PXE, then you also get some integrity protection for state, if your AS is trustworthy.
And well, if state is opaque to the AS, so it could be modified at any other point or potentially injected. So just because you're using... Microphone. Justin can't hear you.
You can't inject it, because if you check the PXE verifier, then the URI was not injected. If you assume that the whole URI must be injected.
I'm not assuming that the whole URI would necessarily need to be injected.
Let's postpone that.
The AS could inject it.
Let's. That seems like a different discussion here.
Thorsten again. I took notes. I will create issues for the security BCP. We're going to work on that.
Thank you. Thank you.
Thanks.
Okay. Two quick, hopefully quick ones. So like I mentioned earlier, one question is, if we're going to require PXE, is S256 reasonable to require in a browser, and are there good enough JavaScript libraries for it? Or is there like a browser library that can do these hashes now? Or do we need to allow plain in the browser-based app scenario for a while, even if it's not necessarily the best practice? Does anybody have experience on that front?
Mike Jones, web crypto is pretty commonly deployed now.
Yeah.
+1 to, sorry, this is Philip Skokan, Auth0. Web crypto is there, widely supported. The only problem with that, it is promise-based, even for SHAs, even for hashes. So if you're going to do anything like a pop-up mode where you want to open a new window to do the authorization dance in, then you might run into issues where you can't open the actual window after the promise has been resolved.
Interesting. Okay.
So you need to calculate the hash before you actually you have it. You need to have it ready at the time the user presses a button. For instance, it's a gotcha.
But it's possible. It's just a okay.
Yeah, I think there's workarounds for that. And there are a lot of other problems that you run into trying to deploy a pop-up based, speaking from experience, trying to deploy a pop-up based OAuth experience that I don't think it's I don't think it makes sense for us to restrict our guidance based on that particular use case.
Great. So it seems I'm getting a sense it's probably fine to require SHA-256 hash. The last question I had with the 1 minute left. Am I doing okay?
Take a little bit.
Okay. The last point I wanted to talk about was about passwords. I know there's been some more talk about that lately as well. Right now the browser app spec does specifically say that you should either do auth code in Pixie or use the password grant for JavaScript apps. And I would, for many reasons, like to avoid recommending the password grant at all. So I'm wondering what we can do on that front. So any thoughts?
I'm going to surprise people by saying we should get rid of the password grant, especially in browsers. The one possible justification for the password grant is, oh, but what if I don't have a browser? I think that argument really doesn't hold up when it's a browser-based app.
The argument I normally hear is that people don't want to deal with the redirect loop or pop-ups or that kind of thing. So
Ludwig Seitz for Justin again. He wants us to burn it.
Thorsten, +1 to both. And I also would like to add, there are also functional reasons why I think the password grant is just legacy. I mean, we talked about that at IW. No federated identity, no two-factor authentication. So this discussion typically is much too limited. So we should get rid of it.
So as the burn it, get rid of it option, does that mean the browser-based app should not mention it or explicitly say don't do it?
Thorsten again, as you have seen, this is one of the open issues we will be working on in the security BCP. So if the SPA BCP just follows the recommendation of the security BCP, I think once we discourage use of the password grant, you no longer need to really mention that, unless you really want to. But I don't see a real need for that.
Okay. Annabelle Backman again. This might be able to go further than the security BCP in that the use case that was mentioned, the rationale behind password, the password grant is wanting to avoid redirects and whatnot. There are other ways to do that if you're already in a browser environment that normally we would recommend against, things like embedded iframes, that if you're going to accept the security world of collecting passwords on this other site, then the concerns around embedding an iframe there, or embedding your sign-in experience in an iframe on that page don't really register. Like if you're accepting one, you're going to accept the other. So there's really, at that point, no reason to need to have the password grant. So even if the security BCP says not recommended, we might consider a must not here.
Okay, thanks. Yeah.
Aaron, for the benefit of Tony, I don't know how, there was a lot of discussion. Do you want to summarize briefly what you took away from the discussion here for these questions and for the other?
Yeah.
For a future update of the document?
Yeah, so let me go back here, try to summarize what we just talked about so I know what I'm walking away with. The scope of this document will be any app running in a browser base with browser-based execution that is involved in the OAuth flow, whether or not it has a backend component at all. Yeah, both cases. It'll cover both cases, and it'll mention both explicitly as different deployment scenarios. And I think I'm going to have to reorganize how this document is laid out in order to better present that as the scope, but I can deal with that later. We are going to continue talking about the Pixie issue in the security BCP context. I'm going to leave that alone in this document for now, and then probably adjust this to match whatever this outcome of the security BCP discussion is. But I'm not going to change anything in this document with that right now. I think that the outcome of the first point here was that there isn't really any valid reason to allow exceptions to the exact matching of redirect URLs. So I'm going to take out that recommendation or that suggestion from this document, and just you have to do exact matching like every other OAuth app. And S256 is fine. So I'm not going to mention the algorithms here because the security BCP already mentions that. And around passwords, it sounds like the consensus here is to not allow passwords in JavaScript apps, and we should probably continue that discussion on the list for a little bit, but the direction we're going to move there is hopefully to explicitly disallow password grant from JavaScript apps, even if the security BCP doesn't necessarily go that far with that recommendation.
Okay.
Is that it? Did I cover it? Anything else I forgot? Great. Thank you.
Thank you very much. It was a great discussion. Okay. Okay, Hannes with POP.
I keep it fairly short. Okay. Yeah, so I shipped a draft update before the IETF meeting 06, and actually I was working with Mike yesterday to fold in some of the comments that were posted to the list by James Manga, and had a version 07 published. To summarize, so we had the POP token usage for HTTP specified in OAuth working group, but the COA-based version, or potentially for other IoT-related security protocols in the ACE working group, we had a lot of back and forth, which luckily came to an end in terms of aligning the two. So that's thanks, Ludwig, for that. So, but of course, they can be combined. Both of them can be combined as well. So you can use the HTTP-based interface to obtain a access token in a CWT format and pass it along on some COA-based protocol as well. That's good. So we had in this document, the OAuth working group document, we separated out with an earlier version, we separated out the functionality of requesting and obtaining that POP-based information, and in everything related to the token was in this document, but the resource indicator aspect were separated out into a separate document. I'm sure you recall the discussion. The document is currently in, I think, with the ISG. So that's great. Ludwig has written another document, the ACE OAuth parameters, which describe the parameter encoding for in CoAP for the parameters that are also listed in here. So that's pretty good. There's one thing I wanted to point out, which is also in the latest version included in the reference, that we actually have an absolute URI in the resource indicator, on sort of in the resource parameter, and a logical name in the audience parameter, which are separated out in two different documents. So I included a reference because that was created some confusion on the list. When I posted the version right before the IETF meeting, which was really only an update to take some of the most recent developments into account, and I then got this review, so a couple of copy and paste errors, which we fixed, and a couple of additional notes we added. So this was fixed with version 07. So I think where we are with this document right now is, I think it's ready for working group last call, unless you think you disagree.
Anybody has any thoughts about this? Any disagreement?
Torsten, just one question. While we're working on the Depop draft that you're gonna get to know in this session, I realized that Depop just indicates the public key or sends the public key that it wants to bind the token to the AS without any proof of possession. That's correct?
That's one. That's what the
We
Depop-
talked about that. Depop does it, but not pop.
Oh, right.
Not pop key distribution. That's. I mean, this is about working group last call for pop key distribution,
Yeah,
right?
it should allow that option too. It actually should allow both options because we rely on. It should do both.
What means both options?
To just send the public key from the client to the AES and to have it included in the access token. Is that what you're asking?
No, I'm asking for a proof of possession, so the client also demonstrates that it has control or possession of the private key corresponding of the public key. It wants the access token to be bound to.
Yeah.
We identified that it is a need for Depop.
Yeah.
My question is, have you analyzed the security implications? Because someone could potentially inject a public key or something like that,
Yeah.
and just make the access token to be bound to a completely different key pair. So have you analyzed the security implications? I mean, we could also simplify Depop if it turns out there's a need for that.
We did for the OAuth case, for the ACE OAuth case, but we probably should dig this up and double check it, make sure that it's actually correct.
Ludwig Seitz, as himself. In ACE, we require public keys, the proof of possession for a public key that the client requests the AES to include in a token. And honestly, I would like to hear a very good scenario for where we would want not to do that in OAuth. Because why should we let someone inject the public key in a token when we don't know whether he's in control of it or not?
Well, how do we do that in ACE?
In ACE, we require the secure connection between the client and the AES to use that public key. It's client authentication. So basically, if you do like the DTLS with the raw public key, you should use the key that you're planning to ask the AES to include in your
I
token.
need to double check that because I don't think there's text in there which says that the key that you include in the token is actually the key that you use then for client authentication to the AES.
So it sounds like we need to do a review, that there may be some implicit assumptions in ACE that may not have been carried over into OAuth. In looking at this over the last week, Torsten and the rest of us feel strongly that in order to register a key to be used as proof of possession, you must demonstrate that you actually control the private key as part of that message exchange. So that, and as Torsten points out, that isn't actually a requirement in pop key distribution.
Ben Kadek, first, John, thank you for saying that. I totally agree. I came up to the mic because of this comment about the public key that you're using in the DTLS handshake being expected to be the key that is in the token. And that seems kind of questionable from the cryptographic standpoint in terms of using the same key in different scenarios.
Well, but also later from the communication to the resource server, even with MTLS, when we bind the token, we have the key that we use in TLS is the one that is bound to the token. So in that sense, that would follow a very much a similar pattern used already in other documents. But probably we have, no, I don't think we have to look. We discussed this.
Yeah, we should probably look into it and talk about more on the list.
Good points. Yeah.
Torsten, yeah, that's the way the MTLS works. And we also had a discussion in Bangkok whether we would like to add another parameter and allow the client to request a token binding to a different public key. And we decided to not go that way, because the German typically used to say that opens a can of worms, and he convinced us. So we are relying on the proof of possession that's being provided by the client authentication. Yeah. And I think that would make sense for pub key, I forgot the name, key distribution as well.
Yeah. Okay. So John Bradley again. So I understand Benjamin's concern and agree with it. So it depends on the proof method that you're using to the resource. If the proof method is perhaps signing an object, but you're proving possession over mutual TLS, then those are kind of two different uses of the key and would be considered different in my mind. In the mutual TLS draft, we're using mutual TLS client authentication to establish the key and to prove the key. So that's kind of a special case where you're guaranteed not to have different uses of the same key. But in a more generalized case, if I was wanting to do TLS to the token endpoint but have a different signing key, then arguably I may want to have different protections because there are different security concerns around how I protect a TLS key versus a signing key. They might be in completely different infrastructure, et cetera, and it might be a really bad idea to reuse the same key.
Yeah. Well, we can analyze it because we have the Tamarin model for this sort of scenario. So have a look whether that makes any difference.
Ludwig Seitz relaying Justin from Jabber again. This draft is only a half solution. It doesn't do us any good without a presentation mechanism like the HTTP signing draft that this group has never had an appetite for, apart from Mike's recent review. Thanks for that.
I disagree. Now with the mechanisms developed in ACE, it's actually, this is a model that we have in one of our products.
Go ahead.
Annabelle Backman, AWS. I think requiring proof of possession makes sense. I'd argue strongly against coupling that to the TLS layer. One of the knocks against mutual TLS in some scenarios, using that for client authentication or even TLS token binding, is the fact that it blurs the layer boundaries, and that turns out to be quite complicated in distributed systems and non-trivial cloud environments where you've potentially got very disparate systems involved in each of those layers, and sharing keys across both of them is complicated, to say the least, and potentially inadvisable. So I'd say if we don't have a strong reason for requiring implementers to cross that boundary, then we should stay away from that.
So I hear that there are a couple of investigations we have to do, a little bit of formal analysis to see and take some of that feedback into account. So we'll do that.
Just to clarify, there seems like there's two different concerns. One is the security implications of using that key in multiple ways. The other is the technical challenges for deployment and implementation in some scenarios.
I understand.
Ludwig Seitz, but I seem to understand that we all agreed that a proof of possession for a key that you're requesting to use as a POP key is a good idea. Or is anyone disagreeing with that?
We still wanted to sort of, it sounds like a gut feeling. I think we can still do a formal analysis of this.
Right. So I think that as a matter of first principles, proving that you control the private key for a public key that you're registering is a good idea to be part of an atomic transaction. Whether you prove where it gets gray is if you're using TLS to prove possession of the private key that you then intend to use at some other application layer, et cetera, that in Annabelle and other people's minds, that's where it gets a bit slippery, using a proof from one layer at a different layer. So that's what we need to look at. It's not that we don't want it. I think everyone thinks that, yes, providing a proof is important, perhaps required. It's how the debate is around how you provide that proof and whether or not we're crossing boundaries.
But I still think it's we should go more to a mode of where we actually have some hard data to back up our arguments rather than gut feelings on what seems good or not.
I'm well known for going with gut feelings, but I understand your argument.
Just to finesse what I think I heard Roman Donato is, it sounds like we want to do the POP. The question is, do we have confidence in the proposed kind of approach? And there were kind of some pokes at, hey, let's kind of talk about where I have some concerns with my confidence in that.
Dave Robin, I understand the security implications of saying that I want you to sign it with that guy's public key, but I don't control that public key. However, that is a legitimate scenario of where that thing is deeply embedded device and I am a sophisticated device and I'm getting access tokens on his behalf, but I don't actually control any of the credentials that he has. I don't control his private key. I need you to make a token and give it to him. I need to give it to him because I have a back channel to him and you don't. So there's no introspection possibility. Anyway, it's a scenario that I don't want to completely discount.
Yeah.
That I have some sort of big sophisticated thing that's getting access tokens on behalf of deeply embedded products and jamming them down in there. And I can't prove that I have his private key, but I need you to bind it to his public key.
Torsten, just as a reflection, if you've got a back channel, if you got a back channel to this not so sophisticated device, it could also create a proof of possession for you for actually sending the authorization request. So it's not really precluded, if just as an idea, right? What I would like to say is that as an observation, in MTLS and also token binding, we always enforce the client to really demonstrate proof of possession before we bind the key. To me, that feels like a design pattern or design principle. And my feeling is we should follow that principle, except we have a really good reason to have more flexibility. I was arguing towards, let's build in this flexibility into MTLS, because that would allow in exactly this kind of scenario that someone gets a token for someone else, but you really need to understand the security implications. So.
Quick comment on your statement there. It might be that the back channel is not readily available. You might, if you want to do a proof of possession, you need a kind of nonce from the AES. And if your back channel involves going to the device and plugging into it or something, then that's not a good option. Just clarification.
But then you couldn't get the access token to it.
Yes, you can. You store it, you walk to it, you plug in, and you send it there.
Why don't you obtain it in that very moment?
Anyway, comment from Justin. Isn't that enabling a man in the middle that we can't prove? And do we want to do that?
Annabelle, again, kind of to that point, I think we want to consider what use cases we're kind of trying to optimize for here. I think the one just described is that there's a valid use case there, but it's also nuanced enough and has enough unique characteristics that it may be worth treating that separately and tackling that scenario separately from the kind of more general case where this we can make some somewhat narrower assumptions.
I agree entirely and withdraw my comments. This is an ACE issue. This is, deeply embedded offline. You can't go get the proof of possession because my back channel is not up. I got it yesterday. I'm getting the token today. I'm going to give it tomorrow. So, but that's an ACE issue, I think. So we'll take it out of this group.
Okay, so in any case, good feedback. So a little bit of homework to do in this case. So I guess that answered the question mark here after the working group last call.
Good. Good discussion. Thanks. Torsten?
Oh. Wake up.
You've heard about that? Okay.
You drive.
Thank you very much. So, good morning again, Torsten, yes.com. I've got the pleasure and honor to present the current status of MTLS on behalf of Brian Campbell. Brian, you are supposed to enjoy your holiday right now. All right. What is MTLS all about? I mean, we've heard about MTLS in the comment in the last couple of minutes. MTLS is a mechanism that utilizes TLS client authentication for two different use cases. One is the authentication of the client towards the AS, and the second one is to use the key material to bind the issued tokens to the private key that's being used for the TLS connection on the client side. So basically, it's an alternative to token binding and something we will see later on. All right. What happened since Bangkok? First of all, there was an AD review, and there was a discussion mainly around subject alternative names to be included in the PKI mode, and a discussion about how we make sure that, for example, SPAs or applications that run in the browser don't really collide with the way client certificates are being managed or are being exposed in the user agent. So let me go into the details. As requested by Ecker, Brian included a abstract protocol description into the introduction of the document to make reviewers or to make it easier for reviewers to understand what we are doing in MTLS. There were also new metadata added, so now it's possible for a client to register more than the subject DN to being identified based on the data in the certificate. So there are a couple of new options. One of them is the email address, one is the IP address, one is the URI. That's based on a request being done by a representative of a, let me put it that way, a microservice management framework. So it's more being meant to use in that kind of environment. And then, as I mentioned, there was a discussion about MTLS and browser-based apps. I think Philippe raised that question. Thanks a lot for that. Because as he pointed out, when you want to use MTLS in a browser-based application, you will be experiencing the sometimes really awkward user experience that the user applies when the TLS enable endpoint asks the user to present certificates. Our recommendation for MTLS to set up the token endpoint, for example, in a mode that optionally supports TLS client authentication. So the client may decide whether it's going to use client authentication as a method or any other method. The problem is in user agents or in that environment, the server anyway sends a first message and asks the user for the certificates. And in native apps and other apps, this is just suppressed. Whereas in a browser, this typically will pop up a dialog asking the user, in some circumstances, what certificate to use for that particular connection. And that's really bad because the certificates we're going to use with MTLS are device application-bound certificates that have nothing to do with the user identity. So the user is not really aware of the existence of those certificates, and that's okay. So since there is no way to control that from within the app, the solution being proposed and also documented right now in the draft is that the AS can maintain one set of TLS endpoints that are configured to support client authentication, so they are MTLS ready, and another set of endpoints that do not require any kind of TLS client authentication. So any client that's not MTLS aware just uses the AS metadata, obtains all the endpoints, and works as normal. And all MTLS aware clients can use the alternative endpoints to actually kick up the process. The questions being discussed on the list was more how we actually represent this kind of metadata. And there were two options being proposed. One was a completely alternative AS metadata file, and the other one was to include a section into the standard metadata file called, I think, MTLS endpoint aliases, and just add those endpoints to that section that are relevant for MTLS. So, for example, the token endpoint, potentially introspection, and revocation. Oh, Mike, okay. Okay. Yeah, and that one there were some editorial changes. So, for example, the explanation of the confirmation introspection registration went to the IENR consideration. And then there is a clarification type of a change, or one could also see that as a functional extension. The draft now describes how for public clients, MTLS can be used to sender-constrained refresh tokens as a mechanism for replay protection for those kind of tokens. So we now have, for public clients that do not really authenticate towards the AS, the ability using MTLS to sender-constrained access tokens as well as refresh tokens, which greatly increases the security for this kind of clients. Then there is a new privacy consideration section discussing the implications of the way certificates are being handled in TLS up to version 1.2, because in that case, the public key certificate is sent in the clear, so the implications regarding privacy is now also discussed in the document. And there is some more text about hash algorithm agility in the security consideration section. The rest includes more or less editorial changes, including removing a bit of the influence of my mother tongue. Let's see. Huh? The German influence? All right. Yeah, that's about it. So Brian plans to also add some little explanation or more explanation about the way refresh tokens are being handled indirectly for confidential clients. And then we hopefully can move that draft forward. Any questions, comments? Hey, Annabelle, I've been waiting for you.
You're shocked to see me coming up here. Annabelle Backman, AWS. So I want to talk about the metadata for the MTLS endpoints. A couple of points, a lot of this stuff I brought up on list, but I want to share it with the people who are here. Firstly, I think the example, yeah, that one. I believe that violates RFC 8414, the authorization server metadata spec, because that spec says regarding, oh, where was it? I had it up here. Regarding the token endpoint auth method supported, that it is optional a JSON array containing a list of client authentication methods supported by this token endpoint. In the context of the spec, that means the token endpoint listed in the token endpoint property. This is suggesting a change in the interpretation of that value to where it now means a client authentication method, a list of client authentication methods supported either by the token endpoint or the token endpoint under MTLS endpoint aliases. So that sounds to me like a potentially breaking change. And if we're going to make that change, we should at least be deliberate about doing so. So
from my understanding, that might be right. I think we should be waiting until Mike arrives again, so you can comment on that more deeply. I think the assumption is that the MTLS aware client first looks up the authentication methods, see there is TLS client authentication support, and then
looks for the MTLS endpoint aliases. I think we could couple with the issue you just raised by just having a copy of or a redundant token endpoint auth methods supported in the MTLS, let's call it metadata, and have those elements added there to this particular claim. I think that should be feasible, because in the end it's the same way as the alternative metadata would work. Because you would look for the alternative metadata, and then if that does not exist, you would fall back. So it's the logic is quite the same, I think.
Well, it was that first step that led me down the path of going, hey, let's just make this a separate document, because that way we don't have to worry about other issues like this that may come up in the future, as there are further iterations on what goes into the authorization server metadata, as like every single new spec that comes along practically is introducing new properties there. Which gets to one of the other concerns I had, which is around, are we requiring now that every spec that introduces a new endpoint property also has to define that under MTLS endpoint aliases? It looks like the language in MTLS right now is kind of fuzzy around that, and is sort of saying, well, anything that's an endpoint property can also go under MTLS endpoint aliases, and maybe that's adds enough flexibility there that we don't need to expect people to be too explicit. But again, I just want to make sure we're being intentional about that. My big concern here is that we are thinking about how this might, how authorization server metadata and client authentication may evolve in the future, and making sure we're not boxing ourselves into a corner here. One thing that came to mind thinking about this over the last day or so is in TLS 1.2 adoption, I know of some cases where we had to roll out new endpoints to support TLS 1.2 because of legacy deployments that were going to still hit those old endpoints. We couldn't turn TLS 1.1 off on those. That raises the question of whether or not this is really like a one-time issue with MTLS, or if there's going to be other use cases we're going to have where we need to kind of fragment the endpoint space along various parameters, and if we should be thinking about a broader solution for that.
Thank you, Annabelle. Any comments on that? What's your opinion, your thought about that? Mike, welcome back. Annabelle just raised the issue that the syntax as shown in the example violates the IS metadata RFC, since the TLS auth client auth method is contained in the token endpoint auth method supported, although the token endpoint in the same context does not support MTLS.
I don't think I understand.
I can restate my objection. So if you look at the text for 8414, it says that the token endpoint auth method supported is a list of auth methods that's supported on the token endpoint. That's plainly no longer the case here, because now it's a list of auth methods supported on one of these two token endpoints. So that is a change in the semantics of that property. Right, we should make sure we as a working group are comfortable with that change, or if we're not, then we need to think through how else do we do that. It's as a further example of where this potentially goes wrong is, like, in this context, we understand really this only applies to TLS client auth, but outside of the context of this room, somebody looking at this do they understand that? Do they realize that, okay, TLS client auth is supported on this endpoint and everything else is supported over on that endpoint? Or is there a question of, okay, client auth is supported here, client secrets supported there, JOT was supported over here? Like, how do they split up the elements of that list and make sense of that? This is where it starts getting into a lot of room for ambiguity on the implementer side, trying to decipher what this is supposed to mean.
I'm gonna cut the mic after Mike.
And Mike Jones, I haven't read the draft in a while, but the MTLS endpoint aliases list, those are the ones that you are doing mutual TLS and they're in parallel with the others?
That's the idea, yes. So any traditional client just uses those that don't cause any issues, and those that are aware of MTLS use the other ones.
You know, this is JSON and we're doing flexible metadata. I would be fine with there being a note in the definition of the TLS client auth value to be included in the token endpoint auth methods, saying that in this case that actually applies to the MTLS endpoint alias list.
So you mean this would go into the MTLS draft and relate to the client authentication methods defined in this particular draft?
Yeah.
Okay.
Just as long as we're clear with people what things mean, I don't think there's a serious issue. But thank you for Annabelle for pointing out the ambiguity.
+1 for just being intentional and clear. Like if we're comfortable making that going that direction, then let's just make it clear in the doc.
Okay. Thank you.
I actually lean towards repeating the token endpoint auth methods inside of the MTLS block. I think that would actually be clearer that mutual TLS isn't supported on the non-mutual TLS endpoint, which some people will become confused by.
So basically means, Thorsten here, leaning towards an alternative configuration without having the alternative configuration in a different file.
Yeah.
That would be fine.
Okay. Thank you. Okay. I want to talk about the nested JOT. So just a quick background. So most people probably know that. JOT has it defines the concept of a nested JOT where one JOT is contained inside another JOT. So there's a current limitation with the definition today, where the outer JOT is not allowed to have their own claim set. So it only contains the insider JOT. So the goal is to try to extend that scope and allow the outer JOT to have their own claims. And the draft is just defining a new content type and a new claim to contain the insider JOT. And here is a quick example of how would that look. So, and I'm running quickly with this because I want to allow yet another presentation to happen. So, and I think it's simple enough to maybe quickly talk about this. Go ahead.
So Roman Danilio, the draft is actually very, very simple.
Yeah.
What I didn't kind of catch is what's the OAuth specific motivating use case as we think about the chartering part of this?
Yeah. Okay. We'll talk about those motivation. Any comments about this? Any concerns about this? Does that make sense in general? Okay. Okay, good. Thank you. There you go.
Thank you. Thank you. Daniel Fett with yes.com. My first time here, and yesterday I uploaded my first draft. Demonstrating proof of possession at the application layer. So this was an idea that came up at the OAuth security workshop last week in Stuttgart. The problem is, we heard about this before, so the OAuth security BCP recommends to sender constrained tokens, which absolutely makes sense. But OAuth lacks a suitable mechanism in an SPA, or let's say in a browser-based app, or whatever you want to call it. So we have MTLS which doesn't have a nice user experience, and we have token binding, which lacks browser support, so we need a new mechanism. The main goal of the new mechanism is to prevent an adversary that gets hold of an access token to use that access token at some different server. So, for example, if the adversary is a malicious resource server, we don't want that resource server to be able to go to another resource server and use the access token there. In this proposal, we want to define a mechanism that can be combined with any client type and any client authentication method. We want to follow the rough idea of the token binding approach. But signatures are used only for the proof of possession for the public key itself, for the private key itself, and also for replay detection, whereas the for message integrity, we have to rely on TLS. To give you a brief idea of what the current approach looks like, in the OAuth flow, we have in step C the token request, and to this token request, we attach a depop binding that is a signed JWT that contains a public key, and also information about the request in which it is used, namely the method and the path, the URI, including the path. And this is signed by the client using a freshly chosen private key. And the authorization server receives that and can then check that the claimed public key or that the public-private key pair matches, can check the signature, and then bind the access token to the public key presented by the client. And then when the client wants to use that access token, it sends a so-called depop proof, which is a JWT, which is again signed by the same public key and again contains information about the endpoint where it is used and the request where it is used. And the resource server can now check that. If the access token is a JWT, then in the access token, you probably would have the public key signed by the authorization server so that the resource server can just check the public key. Otherwise, if you use token introspection, then the resource server would go to the authorization server and in the introspection response, receive the public key, which was presented by the client earlier. We can also use, especially for public clients, the same mechanism if you want to get a fresh refresh token, if you want to use a refresh token to get a fresh access token, there you would obviously also be able to attach a new proof and maybe also even bind a new public key and rotate that in the process. This is what the JWT looks like. So very simple. Type is a new type, depop binding plus JWT, key in the header, and the information about the request, the method, and the UI, and some data for replay protection in the body. So as I said, I published the draft yesterday. I sent an early version around already. We have, I got a lot of feedback on that. Still a lot of points open for discussion. This list is actually not complete. So we need to talk about whether to transport it in headers or in parameters, what we want to maybe include in the JWT body as well, some syntax clarifications, and of course we need a thorough security review, if possible also with formal analysis, and then also complete the security consideration sections and some other to-dos. That's it.
John Bradley, Yubico. So by way of sort of explanation of the origin of this, we sat through some long explanations about XSRF attacks on single page applications. And at the end of that, we decided that we should just completely eliminate browsers because they're an attack vector.
Agreed.
Short of that, the binding tokens to the browser instance doesn't solve all problems because an attacker can still take over your JavaScript app and wield the tokens inside of the user agent, but not allowing the attacker to exfiltrate those tokens cuts down a bunch of things that, forcing them to use it inside the same user agent gives you more options, more ability to detect something horrible has happened. So in order to come up with a way of not exfiltrating, the observation was made that, yes, we do have web crypto now, and you can create keys that are non-exportable in the browser. So this was a mechanism of essentially, we have Justin's HTTP signing draft, we had Nat's JPOP draft. This is cutting all of the stuff that wasn't absolutely required out of the proof mechanisms. Now we're probably going to have a long discussion about, yes, I want to add back signing the header, signing the body, and various other things. And those are all debates that we can have going forward. This is the sort of minimal subset that one would need to meet the basic use case. There's nothing that would stop us from adding back all those canonicalization options in the in the proof for the access token. But this also, we're also focusing on not forcing people to do pre-flights by requiring use of a header. So there's a bunch of things when you're doing cores that have to be taken into account. So you can double the amount of calls that a single page application has to make. We're trying to avoid doing that. So this is targeted, but people will undoubtedly argue that we should add back a whole bunch of other stuff. So
Okay.
it's not the end of the discussion, the beginning of the discussion.
Thanks, John. Mike.
Mike Jones, Microsoft. I think it would be useful to explain to the room, because most people weren't in Stuttgart last week. There's a whole bunch of different kinds of OAuth applications. There's native applications, there's single page applications, there's web applications, etc. Which of those is this mechanism applicable to?
So I see it mainly for browser-based applications at the moment. So I don't know whether other people can come up with other use cases where we really need such a mechanism and can't use a better mechanism like MTLS. So browser-based applications, I think that's the main use case here.
And I know that people want and or need a proof of possession mechanism for web-based applications. Will this work or will it not?
So I need the work group, like the chair is already here, so we're out of time here. We'll have to take it offline. Okay. Thank you, everyone. Sorry.
Well, you mean a single page application.
Ist das DP binding vielleicht das Socket?
Can we get the blue sheets, please?